Hello and welcome everyone to this series of webinars about CAD, PLM, and augmented reality. I'm Richard Bresson, the account manager at Parametric Design Canada, and thank you so much for joining me today. So this is the first episode of a series of webinars, and today with me there is also my colleague Marco Bellusci. Marco Bellusci is the technical application specialist and multi-physics simulation analyst, and will be sharing some insights about Creo CAD and presenting a case study, a specific case studies about the optimization of an elevator pulley with generative design. I'd like to invite you to write any question you may have to our email address at contactive@parametricdesign.com. But before we begin, allow me to provide you with an overview of Parametric Design Canada. So at Parametric Design Canada, we are technology advisor, specializing in helping companies excel in their product development process through powerful and innovative software solutions that adapt to various market needs. At Parametric Design Canada was established in 2001, and so with years of experience supporting companies of all sizes and across different sectors, we have created a wealth of knowledge and expertise. And these enable us to offer tailored solutions that accelerate your process and increase your efficiencies. As an authorized as a retailer and partner for an esteemed software provider such as PTC, Parametric Design Canada offers a comprehensive product suite to meet your requirements. Our range of solutions includes CAD 3D, PLM, ALM, augmented reality solutions, and industrial Internet of Things. We are recognized as a valuable partner of PTC, and with us, you can gain access not only to a software solution provider, but also to a dedicated team of professionals who are passionate about your success. Here, I'd like to present you some of our industry references, and we can start with transplantation references. You can recognize names such as Piaggio, for example, or Beta Motors. In the design references, we have Tiffany & Co., Momo Design, for example, and their names. The oil and gas references are, for example, Paul Wurth, who doesn't know this company. And consumer goods references, we have names like Bialetti, Ferrero, Lavazza, Samsonite. We have also expertise in the medical and wearable technology sectors, and these are the names which we are working in. And our industrial references, you can recognize for sure Schindler, the elevator maker company, and so on. But now let me hand the floor over to Marco Bellusci and Creo CAD. And thank you so much. And Marco, the floor is yours.
Hi, everyone, and thank you very much, Richard, for your introduction. Before starting, I want to remind you that you can contact us at contatti@parametricdesign.com. Please feel free to write us for any comment or question and so on. In this presentation, I'm going to show you a general introduction to generative design and a case study of this technology. The case study is related to the pulley included in a reducer for elevator machine. You can see the component highlighted in red in the sketch in the bottom, and you can see the original design we considered for this component in the top right. The goal here is to optimize the component considering all the requirements, the loads, constraint, manufacturing process, and so on. The problem has been solved with PTC Creo generative design. This is the index of our presentation. We'll go through an introduction to generative design, then we'll go to the case study, we'll present the workflow, then we'll have a live demo of the simulation setup, then we'll see the result of generative design, and then we'll have a final verification. Let's start from the first point. What is generative design? Generative design is a tool that autonomously create optimal design considering all the requirements: load, constraint, material, manufacturing process. For example, let's have a look at the picture at the bottom. Let's say we have to define a working area in transparent. The starting volume we have to consider it in transparent. Then we define the blue volume that are preserved area, volume we want to keep because, for example, they define interfaces with other components. Optionally, we can define volume we want to eliminate in red. And then we set up a simulation. We set up the constraint, we set up the loads, we set up the material, and we can also set up some constraint from a geometrical point of view related to the manufacturing process. What we get from generative design? We get this design, the optimal design for these requirements. A shape that reduces the mass and that minimizes the distortional energies. And this means that it should have the best mechanical performances considering these requirements. Generative design, PTC Creo generative design also gives you the possibility to have a preliminary the result of a preliminary mechanical analysis directly inside Creo. So you can have a look at the displacement and internal stresses of the resulting geometry. So you can have a preliminary evaluation of the resulting mechanical performances. But why do we need generative design? First of all, engineers need and want generative design. Why? Because they want to deliver design that is right at the first time. Consider the case we are developing a brand new product. We are in the dark. We have only limited information that come from previous design, some numerical simulation on old design, and so on. But we are basically in the dark. In this case, generative design helps you and guides you to the optimal shape for your requirement from the start, from the beginning, letting you understand where you need to put material and where not, and so on. Engineers also want to deliver radical design change and innovation. Consider the opposite case. We are working on an old product, a product that has been on the market for years and maybe has gone through round and round of small innovation. But now, and some rounds of improvement and change and optimization. But now we want more. We want more. And for having more, we need some radical change. In this case, even in this case, generative design can help you because generative design can provide some radical brand new shapes that are optimal for your design. And in general engineers want to deliver the optimal design to meet criteria and objectives. But companies also want generative design. Why? Because they want to increase their profits. How they can increase their profits? They want to sell more products. And for example, they can sell more products, increasing the product performances. And in this case, generative design can help in finding the optimal design that gives you best performances. Companies want to cut down the cost for increase their profit, the profitability. And in generative design can help you, for example, in cutting down the material cost of your product. Company wants also to reduce aftermarket cost, and by improving your design, by improving your design performances, you can cut down the warranty and repair cost of your product. Another interesting thing about generative design is that it's a valid solution for all the possible scenarios, considering the corner case of low volume manufacturing and high volume manufacturing and all that stands in between. For example, of low volume manufacturing, such as custom products, generative design can help you in improving the performances of your design. In this case, you are usually completely focused on performances and less on cost. In this case, generative design can deliver to you the best shape for your design. It can also be a complex shape that require 3D printing or for 5-axis machining. But generative design is also a valid solution for high volume manufacturing. In this case, maybe you are more focused on cost and decreasing the cost without impacting performances. And in this case, for example, you can have the optimal design, but constraining generative design to produce only simple shape that are good for 3-axis machining, castings, and so on. And another point is that generative design can provide you high-performance cloud computing. That means that you can reduce the time to find your design, the time for your simulation. And inside this tool, we also have some instrument to compare the different design. We can define some performances index and compare the design graphically. And the important thing is that all is, as usual, completely integrated inside Creo Parametric. All this goes in the direction of boosting innovation and productivity. But let's now jump to our case study. This is the workflow we followed for solving the problem. We start by performing a mechanical simulation on the starting model. Then we set up the simulation, the optimizing simulation in generative design, and created the optimized shape for our component. Then we exported the automatic reconstruction by a wrapper model of the component, so the model, and then we perform a final FEM validation. Let's start from the first point. We performed a mechanical analysis on the starting model. Consider that this step is absolutely not mandatory in the generative design workflow, usually. But in our case, it was very interesting because it allowed us to evaluate the mechanical performances of the original design. And this allowed us to set up a baseline to evaluate the generative design results. Basically, we want to decrease the mass and have better mechanical performances. Then we set up the generative design optimization. Let's now jump to Creo. So we are inside Creo. This is the generative design interface. This is the model we used for the generative design optimization. You'll see that the dimensions are obviously the same of the original model. You'll notice a difference here. We define this simple and plain cylinder that we used as starting geometry. Why we use this simple and plain cylinder? Because we wanted to leave generative design completely free to find the optimal solution without any bias from the starting geometry. Then we define the preserved geometry. All these bodies. And we don't have excluded geometry. Then we set up the mechanical description of this load case. We'll have two load cases in this case. We have the clockwise torque and the counterclockwise torque. Okay, let's start for the first one. We set up a constraint here, and then we set up the loads. We'll have a force here in this direction. Then we have a torque always here in this direction. And then we'll have a very similar case, but for the counterclockwise. So I duplicate the case, rename it, and we'll have always the fixed constraint here, the force here, but we change the sign of the moment. Then we set up the design criteria, the geometrical part of this optimization. For example, we set up a volume target, a mass target. Then we add some constraint. For example, we define that this component will come from a casting, so we'll have a draft angle, width, and a parting line on this plane with a draft angle of 5 degrees. Then we add another constraint, a symmetry constraint, a periodically rotation symmetry constraint with 3 instances around this axis. And then we can add another constraint, is the spreading. So it say to the tool how much spreading, how much I want the material to spread in the final design. And this is the material. The material is directly read from the datasheet we set up on the model. And here we have all the mechanical properties. And then if we want, we can also set up the fidelity of the study, that is a compromise between speed and detail. And then the setup is completed. I only have to start the optimization. The optimization took only 6 minutes, and after 6 minutes, you have this result. As you can see, is a completely different shape, a shape that can be easily solidified by automatically by generative design. We can also analyze the results in terms of stresses, for example, for both of the load cases, counterclockwise, clockwise. We can change the limit to put to material limit, considering the safety factor we consider to analyze the stresses inside our design. This is a preliminary simulation. We can analyze the displacement, very small displacement. We can animate the deformation of this result, and we can set up a scale of 10. So the displacement will be magnified by a scale of 10 to be viewable, and we can understand how the design is behaving under this load case. Let's get back to the presentation. So we get this result in about 6 minutes. These results allow us to decrease the weight about 11%. This shape is completely new, and we verified that is completely manufactured. Also, we verified that the stress level is lower than the original design. And the last step was final verification. So we exported this geometry. This geometry is automatically exported by generative design in a solid model, in Creo format, step format, whatever you want. And we performed another simulation with an external simulator, in this case, ANSYS. And the simulation with the same load and constraint and the same material confirms that the stress level is lower than the original. So basically, we are seeing that now we have a design that cut down the material of 11%, a design that reduces the stresses, a design that is completely manufacturable. We are saying that this design completely improves our product. Starting from this point, we started to play a little bit with the generative design geometrical parameters in order to have the possibility to find other possible innovation ideas. In this case, we set up a minimum radius of 50 millimeter and got this result in return. And we have the preliminary analysis that is telling us that the result is good in terms of stresses. And this is another shape we got with a minimum radius of 25 millimeter, another completely different shape. Even in this case, the results are telling us that this is a design with good mechanical performances. And we went on, consider that the simulation took only 10 minutes, 20 minutes, maximum, so you can have a lot of drives. In this case, we maybe played a little bit, we increased the spreading factor. As you can see, this is a very complex design, and in this case, we eliminated this design from our pool. But this design, for example, on the right, has 6 rotation symmetry instances. Why we have to limit to 3 as the original? Why? We put 6 rotational symmetry instances and got this design in return. So wrapping up the results in this slide, it's clear that generative design can be considered as a really powerful idea generator. We started from the design on the left and got all the design on the right that have lower mass and the same or better mechanical performances. So we can say that we produced a lot of ideas for product improvement and innovation. I'm talking about ideas because we are not forced to take exactly this design and go directly to production. We can also consider these ideas as simple ideas for product improvement, general shape for improvement. Before closing my presentation, I just want to show you some interesting things. The first one is actually a thing we discovered by mistake. At the beginning, we, by mistake, set up a simulation, a generative design simulation, considering only one direction torque, only the clockwise rotation and not the counterclockwise rotation. And generative design produced this shape. And it was interesting because it's really similar to something you usually see in a museum, something you can see in very old pulleys. And what's interesting is that in only 5 minutes, 10 minutes, generative design produced a shape that maybe in the past required decades, years of experiment, numerical simulation, calculation, and so on. And what's fun is to think that maybe in generative design we have the power to discover the future shape for this product or any product, generally speaking. Another interesting thing is that we also evaluated other possible innovation for this simple product, pulley. We evaluated the possibility to introduce lattice structure. Lattice structure are structure designed for strength at a fraction of the mass. It's interesting because PTC Creo offer the capability to introduce parametric lattice inside your design. These obviously are complex shapes that require 3D printing. We can have a lot of different shapes, for example, this one or also this one and this reticle too, but we have no time for that, maybe in the future. So closing the presentation, it's really clear that generative design proved to be a really powerful tool and an idea generator that can boost innovation and is available for any kind of product. It can help you in speeding up and accelerate the new product introduction because it points you directly to the optimal shape for your product. It can reduce the product development cost because it reduces the all the round and iteration of analysis, experiment, and so on. It will help you in increasing your market share and revenue because it will allow you to produce better products and a fraction of the cost. It's also very important because it can help you in increase your design confidence and mitigate risk in the early stages of your project. And it will help you in reducing aftermarket service, repair, liability, and so on. And it also help you in avoiding to lose profit resulting from over-engineered products. And with this, I think I can close my presentation. And thank you very much for your attention and your time. And I wanted to remind you again, please feel free to write us for any comment, any doubt, any question, and so on. Thank you again. I think we can get back to you, Richard, now.
Wow. So thank you very much, Marco, for such a great presentation about Creo. So this marks the end of our first webinar. I hope you enjoy it, and we look forward to seeing you again for the next webinar, which will delve into product lifecycle management and the software solution Windchill. A special thank you goes to our marketing department for their hard work in putting all of this together. And remember that Parametric Design Canada will remain available to assist you following this webinar. So please don't hesitate to contact us anytime at contatti@parametricdesign.com for any further question or information. Once again, thank you all of you for participating and have a great rest of the day. Bye-bye.